All right. Welcome back.
Hey,
Talk number two. We were just talking about something. So I shared with Robert um, just about my experience, like how difficult it is for me to find soil. I remember being told to go ground myself by walking on the earth, and I was like living in New York City, and then I just moved to Florida, and I all I could see was concrete everywhere, and I was like, where is earth? Where is soil? Like, how do I actually even touch it?
mm,
Uh, and aside from a random tree surrounded by cement here and there. So yeah, that moment struck out to you, right?
yeah, definitely. It was, yeah, I just hadn't realized that's the experience of someone growing up in a city. It seems obvious, but like soil's always been ever present in my life. And like since I was a tiny kid, I used to just sit in our garden and like dig through it and eat things I found. And like,
What?
it was just to sit in the soil. Um, yeah.
Right.
And yeah, my life's just been full of it. Like my whole life's been about like growing things, eating from the soil, studying the soil, studying it in strange places. It's just like a constant in my life. I cannot get through my head of like I can't imagine that experience of yeah. So
Yeah.
so alien to me.
To be so obsessed with dirt is quite alien to me too. Like for me, soil is just where worms come from, and I heard like of tapeworms that or these worms that come up your feet if you're near it. So stay away. Like I'm, you know, opposite world for sure.
Yeah,
Um,
definitely.
I I wanted to start today with me giving uh like a freestyle summary
Mm,
of the topics that we discussed last time, just in case I learned it incorrectly or correctly, and then we can build upon there. And so, aside from talking about your history of attempting to get a PhD and studying ecology, and then moving on to like studying permafrost, which has to do with soil and like how um, like your theory on where like where environments shift rapidly is like an extremely important learning um, could be happen to learn why change happens so rapidly. And so we talked about that, and there's so much more to explore about your experience as a scientist and a researcher. And then we just started talking about climate and what that is. And so weather is what's happening today. Climate is weather over a longer period of time. Earth has so climate always does change over a long period of time, and it typically has these cycles of this like more profound change, and then like 400 like maybe millions of years you said for it for the for organisms to adapt to this change. Some die out, most adapt in some evolutionary way, and then another change happens. And so the earth's history is like just a change after change. All of these changes are in perspective of the day-to-day weather dramatically changing in a time period. um, and then then we got curious of like what was the change that brought humans to exist and thrive, right? and and then you blew my mind by sharing. So the sun is heating up the earth, sending energy. The the something happens where the earth wants to emit this back. We call that heat. Then we have carbon dioxide as like this blanket that so the heat that the earth emits, like from the sun's energy, the CO2 like holds it, or it keeps it from escaping, which is why we feel the heat around us. And what happened maybe before, like that led to the humanity thriving, is that trees started forming and plants started forming in these swamp-like world, and they just kept growing and they would fall. The environment was in such a place that they would just they I don't know, they would something would happen in such a way that they would just fall into the earth and just build upon each other in layers, which is where coal and oil comes from, which essentially is that CO2 put into the earth so that there was less CO2, so the earth got colder. And then somehow humans were like, oh, this environment is, yeah, something. So that's where I learned oil and coal is crucial for the earth to cool down. And somewhere in this period, we went from swamps to living humans taking over the planet. Talk to me.
Yeah, that's a pretty good summary. Yeah. We so the thing that happens with the trees piling on top of each other is just it's an environment without oxygen, so they're in a waterlogged environment. Sort of like, I always imagine it like this, the swampy forests of Florida, where you have these swamp cypresses growing out of the water. The trees fall over, they're in the water, they can't decompose because you need oxygen to do that. And that's coal. Oil's something separate. Oil is the since saying this, I think about this every time I put fuel in a car. Just it's a marine organism has been swimming around in the sea. It falls to the bottom of the ocean when it dies, and the accumulation of that produces two things basically. One is so this like accumulation happens over time, and as things get heavier on top of it, it sort of compresses those organisms, and it sort of separates them. So part of them is like bone, which is full of calcium, and part of it is the like oily matter of its like flesh. that oil is what we put into the car, and it gets separated out and forms these like pockets within the rock where the oil is sitting. And literally that's what you put in your car, like the fossilized remain of that.
It's literally like dead
marine organisms. It's crazy. And at the same time, there's another process happening in the sea, which is so like limestone rock is sort of the harder parts of the organisms, like the shells. In like younger limestone rocks, you can even sort of see the individual shells, like they're not fully turned into rock. And also at the same time, the ocean contains carbon dioxide, which precipitates out. So it like it's in a balance between the atmosphere and the ocean, and in this balance, some of it is like being removed from the water and forms a like sediment on the ocean bottom, and then that gets compressed into the rock too, which is another way we remove carbon. Yeah.
Got it. So you're saying in addition to the trees, like the ocean has its own relationship with the atmosphere that packs carbon into into these limestones and other things.
Yeah, oil also, and natural gas. We get part of that separation into rock, oil, and natural gas happens. So on top of oil wells, you often get pressurized natural gas, which is actually one way they extract the oil from the well. Like when they drill down this narrow little hole into an oil well, and if it's like shaped like this, like a bubble, If you hit it on the top, you'll get natural gas coming out because it's under pressure. But if you hit it below the gas, the pressurized gas can push out the oil, which like that's the like
Has
gold
like a
rush.
fountain.
Yeah, that's the
Yeah.
gold rush image. And once the pressure is released, the oil will stop coming.
Ah,
And depending on where you hit it, you have to do different things to extract it. So sometimes they pump gas in to push it out. Yeah.
we're training people how to dig out oil. That's fantastic.
Yeah.
That's right on theme.
We're pretty good at that. We we nailed that
Well,
one.
we did. Great. Uh, so let's. So I feel more understanding of the significance of oil and coal, and I still want to complete the picture of what a healthy Earth looks like.
Right.
And yeah, so
So yeah, I think there's one last part of that, and then I'll go into it. But the last part is the difference between photosynthesis and combustion. Like photosynthesis is the process that made this tree, which then got compacted into coal. And basically, it's carbon dioxide plus water plus sunlight. Like those are the things the plant takes in, and then that creates like plant growth plus oxygen. So you're taking in CO2, but you're removing the carbon from the molecule to produce plant material, and then you just let go of the oxygen, and that goes into the atmosphere. And combustion is basically the reverse. Combustion's an oxidation reaction, so it involves oxygen, but the specific one we call combustion is burning carbon, essentially. So it's carbon plus oxygen then goes to CO2, water, and energy. It's basically, they're the opposite of each other. They're one in reverse of each other. So you like take in the plant material, you convert it to coal, and then we dig it up and burn it, which is the direct opposite of photosynthesis. And that'll become important in the story.
okay, great. Does Earth do natural combustion things like, besides us?
Yeah, the natural combustion events. We actually think this is how humanity found fire: is lightning strikes cause forest fires, basically.
Oh,
And the earliest way
Zeus was doing good.
the earliest there are some communities in places in Africa that still do this, actually, where they instead of making fire themselves. So the first time we saw fire was from a forest fire or a savanna fire, but caused by lightning. And the theory is we went over to it and we're like, oh, that's interesting. And then somebody figured out how to store it. This bends my mind every time, but the technology is a hollowed out log with clay ends, and they collected the embers from the fire and stored it in this log, and they could keep it warm and transport it. And then when they wanted to create fire, you took out the ember and built your fire, and then the last thing you did was you remembered to put it back into your log. That's before we figured out how to create it ourselves. That's the earliest use.
Wow.
And there are some tribal societies in Africa who still do that. They still carry around a log. I find that incredible. That's the place nature does it. And I guess the other is in a volcano, which takes carbon. So a volcano is sort of letting out the Earth's own heat. And one process it does is it turns a carbon-rich rock into CO2. Like it outgasses the rock. It's not quite. Is it the same? I guess it is the same. Yeah, yeah. It's like carbon-rich rock. This is also actually related to concrete. It's something we do with concrete, but it takes a carbon-rich rock and gets rid of the carbon as CO2, and that's been a huge control on climate, which I think I'll go into. Like, so I was just this morning looking up the data, and since the last time I looked at it, we got an extra 200,000 years. So when I was a student, we had data going back 240,000 years from ice cores, which are mostly in Antarctica. There are people who've just been, sort of from the 70s, have continually been drilling into the ice really slowly and delicately and just pulling out this like cylinder of ice. And if you look at them, I've been lucky enough to see some of them, and if you look at them, they're like striated, which is often like like a glacier is like that too. Like you get these layers in it. And even in like fresh snow, like on the top of a glacier, you get the yearly layer, and you can see it, but it eventually gets compacted. Anyway, they pull out these cores, and inside the ice are little bubbles, and that's like a frozen piece of the atmosphere. So the deeper we drill,
Wow.
yeah, and this like 20 years ago when I was a student, they'd gone back 240,000 years since the 70s, like the end of the 70s they started. And now we've got 600,000 years, which I remember when we hit 400,000, they were thinking that might be the end of it, like the end of that form of record. There are other ways to get to old climate, but this is the best, like most precise with the, like you can literally go like a few years at a time and just recreate it. So older records, they're like geological, and the distance between data points is like wider. But so we have this incredibly good data going back 400,000, 600,000 years ago. And yeah, they're just busy drilling in Antarctica. So Antarctica is this incredible store of ice. I think in places there are I think the South Pole is 3 miles above sea level, and it's ice. And then in places there's a few miles deep. Like Antarctica isn't solid land, it's a few different islands with like ice in these basins. So there's 3 miles above sea level and then a bit more. And they're just finding these deep points and just drilling down and pulling out the ice. And they're doing it continually. So in that record, we basically have this cycle of what oxygen and CO2 have been doing in that period. Humanity evolved about 200,000 years ago, like our species. So we evolved in the middle of this period we have data from. Basically, if you plot CO2, it just does this over that period. It goes up and down between, the bottom is 180 parts per million, and the top is 280 parts per million. And basically that's like, that's a stable-ish climate. And in there we've had glaciations, and like there has been change within it. And yeah, like the explosion in population we've had, like civilization as we know it sort of began about 10,000 years ago when the ice was retreating, and the climate slightly warming. So, oh yeah, in this stable period, or semi-stable, I guess the key thing is the climate is sort of determined by the land mass. So the land mass is like the area we can grow plants on, and that takes millions of years to change. So the first thing that happened was we had this like land mass appeared that we know, and it's drifting around slightly, but the 400,000 years is a much smaller window. Like the land mass itself is stable inside that, give or take a few earthquakes and volcanic eruptions. So the area hasn't changed and the position hasn't changed. And then what happens is you're down at 180 parts per million, and like the Earth's like ticking along until volcanism happens. And volcanisms happening all the time, and it's like slowly just making that CO2 value rise. It's like converting rock, outgassing and creating CO2 for the atmosphere. So it's like bumping along, and just every eruption you get a little bit more. And what happens is that warms the climate. So the environment warms, which has two knock-on effects for plants. If you have more CO2 in the air, plants become more efficient at using water, which means that they can grow into drier environments. So you're like increasing the land area that plants are grown on. And the same for temperature. As the temperature rises, plants can move polewards and up mountains, and you sort of increase the store of carbon in plants by them like moving their range and becoming more efficient. And then that seems to happen until we hit this like ceiling of 280. And at that point, you've had this like burst of plants, and it's actually cooled the climate again. So now the climate starts cooling. There's less CO2 in the air, so plants become less efficient at using water in dry environments, and it's colder, so their ranges shrink. And start shrinking, the climate cools. Yeah, and we just go back and forth in that cycle. And yeah, so our species evolved about 200,000 years ago in the savannah. And then our like hominins, the like genus, evolved, I think it's 6 million years ago. That's when apes came out of trees and began walking upright, which is they moved from the forest to the savannah, basically. And then 200,000 years ago, we were in this like this environment that basically has plants, and it has this certain amount of CO2 in the atmosphere, and that's where we evolved. And then actually, like unusually for a species, we have this really good ability to create culture, which is our like accumulated learning, which allows us to create technologies which we can pass on, which means we can break ourselves out of the environment that we lived in. That like I no longer have to like be here now with enough food every day to survive that I can just pull from a tree. I can create technology, like I can wear clothes to go somewhere colder. I can store food to do the same. So yeah, we sort of
totally hacked the earth.
Yeah, we hacked it. Yeah, basically. And the thing that isn't stable within these 400,000 years, there's another piece, which is the sun. And the sun's actually the thing, the cycles in the sun are what creates the glacial periods, we think. So we're actually in an ice age right now. We say the ice age ended 10,000 years ago, but actually we're in an interglacial, which is like the gap between when the glaciation is extreme and when it's not. But an ice age is when you have ice on the planet. So we evolved in an ice age, like, yeah. And
Wait, I was with you up until there, and now I need to just talk so my brain can digest.
it's simply a matter of definition. Like, we don't really
Okay.
think this is an ice age, but technically, by definition, it is.
Well, so what I'm trying to understand or have understanding with is like, so I now understand this pattern where CO2 goes from 180 to 280 and then down to 180 and two to, you know, and then there's other things that happen in that, but that's the general consistent wavelength trend of CO2. So in the last 400,000 years, how many times did it do that?
Good question. It's we're in, so about 450,000 years ago there was a peak, and then there was another 300,000, that's two peaks, another 240,000, that's three, and another 170,000, that's four, and then we have created a peak, which is five. So it's about every 100,000 years, it seems, but it's not. It's a random process, so it depends just on the like randomness of the volcanoes, essentially. And then the thing I was about to add on top is there is another layer of the sun, which is having an effect.
Great. So now let's get into that. What is happening with the sun? Like, it has to do with ice age. So
right. Yeah. So yeah, there's several things going on with the sun, and we call them Milankovitch cycles. I don't know who Milankovitch was. I assume it's a person who figured this out, but I'd have to check on that. I assume that's true. And so there are several cycles with both the sun and the earth, basically. So there's 100,000 year cycle where the orbit of the earth is changing, like the shape of it is changing. I'm doing this with my hands, but that's a huge exaggeration. But we're going around the sun, and we go from being ever so slightly more circular to ever so slightly more elliptical. So what happens when you, and we call that eccentricity. That's how eccentric the orbit is, like how far away from a circle it becomes. And in 100,000 years, you get the full cycle. So you go from least eccentric to most eccentric to least eccentric. And that's why that changes the, what does that do? That changes it changes the extreme between summer and winter. So you draw out your orbit. Summer is where you're close. Well, this is why it's really complicated. There's like 4 cycles within each other, but it's changing the distance in the orbit between closest and furthest from the sun, which is changing the difference between when we're hottest and coolest. So
all that has an impact for the pacing of CO2 and like the way plants grow and all that.
Sort of, but it's such a long cycle that what it's doing is it's over a very long, or maybe this is a medium time scale. It's not really geological. It's like 100,000 years. It's changing. It's one factor changing the extreme between summer and winter. Or not even summer and winter. They're overlaid on each other. So it's one factor that's changing. I'll run through the others. There's like 3 or 4 things that are changing how much solar energy is coming into the planet. They have effects on how extreme your winters are. and compared to the summers, they change how much sunlight is just coming in throughout the year. They change, yeah, they change several things, but it's the aggregate of these 4 cycles on top of each other which has the effect. Like, so there's like 4 separate things going on different timescales, which
Got it.
is, it's a very, like, it was a real tricky thing to unpack.
Yeah, it sounds like we could have a whole lecture series on that itself to understand
Yeah,
all the forces at play in this.
yeah.
Yeah. So,
And this, I'll run through them quickly. The second one is a 41,000 years, which is how oblique the orbit is. So that's the like axial tilt. So quite uniquely, it seems, we're, well, at least uniquely in the solar system, we have a really large axial tilt. The axial tilt is we're going around the sun in an orbit and we're spinning. And if you have 0 tilt, your spin is at right angles to your orbit. But ours is like, it's currently like, is it 23.5 degrees? And over 41,000 years, it goes back and forth between 22.1 and 24.5 degrees. So there's like a slight wobble. And that has direct effect on winters. So that changes, it's changing the angle the sunlight's coming in at. And it changes the difference between summer and winter, like the temperature difference. And like depending on the previous one and where that happens in the orbit, that could be masked completely by the eccentricity. It could be amplified by the eccentricity.
sure.
The next one is wobble. I think this is called axial precession. So this is 26,000 years. The Earth kind of does that, if that makes sense. If this is the axis, so the axis wobbles in angle compared to the orbit, but it also just like wobbles around in location.
It reminds me of a dreidel in some way.
Yeah, yeah, it's that point where it's wobbling, sort of.
Got it.
And that also has, yeah, that also has an effect on the angle the light's coming in at on each like spot on the Earth, which changes how much energy is coming into the system and changes your seasons. Yeah, and it changes the point of the Earth that's warmest or that's receiving most sunlight, which we usually think of as the equator, which is not always true, but it can shift like which point that really is. Yeah. And then those things on top of each other create a very, like you can imagine that's a really 3 cycles overlaid creates a really complex cycle that sort of appears random but isn't. And that's the thing having the glaciation effect for the last 400,000 years. So every now and again, we hit a place with those 3 cycles where it gets cool enough that glaciers just grow. And then that effect is that it both removes land in the northern hemisphere at the north, but it locks water up in ice, so you're lowering sea level, which also creates land. So there's like 2 things going on there. Yeah.
Got it.
And like when humanity was moving all over the Earth, the sea level was like lower because we were in a period with more ice when there were a lot of land bridges. Like mainland Europe was connected to Britain. There were settlements in the Mediterranean. Like we have, yeah, there's like geological or archaeological evidence of these settlements.
If we're going to talk more about what humanity is doing and how it's impacting the cycles, but I'm just trying to get a baseline of like what would have, like if it was left alone, this is what would be happening. And what I'm hearing is we still would be creating more ice technically.
We wouldn't. So right now we're in a interglacial. So 10,000 years ago it was, 10,000 years ago the ice was retreating. So a bit earlier than that it was warming, and this cycle of like warming and cooling due to how the Earth moves around the sun is always happening. This has happened forever, like since the Earth existed, and that will continue to go on. But in this stable pocket that we're in, which is partly just due to the timescale we're looking at, and partly due to the like vegetation we have around, where the land mass is stable with this ecology that we live in. Those two factors, you would still create this 400,000 year stable part, but within that you have the solar cycles creating glacial periods and expansion and contraction. But the crucial things are like the land stays the same in that period, and pretty much so does the ecology. It just sort of shifts around and grows a bit and contracts a bit and waits for volcanism to warm it up again, or for the solar cycle to warm it up again. So all those things are laid on top, but it's a stable period in the climate, even though what I'm describing is instability. If that makes sense.
It does to me. I wouldn't be able to repeat all of the factors in, but the level of complexity of what goes on in a time period is revealing itself, and how many different forces are at play. I'm capturing that, and how we're gonna go from that to deducing that something was wrong with the Earth. I'm looking forward to watching you, because with all of these factors at play, I can see how easily people be like unconvinced that something is actually wrong, you know?
That part makes no sense to me, but we'll get
great.
there.
Great. Well, based on what I hear so far, so I'm looking forward to getting there. My simple-minded Western brain wants like something real practical, and how that would look is like the most recent phase we're on is like X amount of years,
Okay, I can do that.
Yeah, and this is where all of the other cycles are in this time period, and we have about X amount of time left before this phase is over.
Yeah, okay. So do we have time for me to do?
Yeah.
I'm just trying to pull the crucial factors out of my mind. So we evolved 200,000 years ago in an environment that was, this is where it gets complicated. So for the period humanity has existed on the planet, the land mass has looked the same, even though it's ever so slightly changing. Like there's an eruption in Iceland, you get a little bit more land. Recently there was one in Hawaii, but like over that time period, the land mass has only changed by like a few, I don't know what it is, but a small percentage of the land area has changed. And it hasn't really moved location. So we've had a lot of land mass in the north. It's been the same shape, less land mass in the south, apart from this like cap on the bottom, which is a chunk of land. So the land area hasn't changed, and the amount of water on the planet hasn't changed on the timescale that humanity has existed. And because of that, like that's the stable factor, the amount of land and water. So, or the land and H2O, I guess. So some of the land area can increase, but only by removing water as ice. But the shape looks the same. When that happens, as you like lock up a meter of sea level, the same amount of land emerges from the ocean. And in that period, and one other thing, that the organisms are the same. Like 400,000 years, even like 600,000 years, nothing incredible has happened. Like there've been a few like incredible moments in the history of the planet which have caused a huge shift, but that has not happened. And that is what we evolved in. And part of that 400, 600,000 years probably goes back quite a bit further. Within that, there's this cycle of CO2 going up and down with the controls of vegetation and volcanism and the solar cycles, which are controlling glaciation. But essentially it stayed the same. Like compared to what's happened in the past, that's staying pretty much the same. And it's the ecology around us that create and maintain this envelope that we can live in. Like we've evolved to breathe a certain percentage of oxygen. We've evolved to cope with a certain amount of CO2. We've evolved to like live in the savannah, but then we could like move further. We learnt to grow crops, but they only survive in this environment. Like we start changing with it, we're actually fucking with the system that allows us to live. And that's what we're doing on a grand scale. And I think people can't quite believe that we're doing that, but like the evidence is there in like coal. If you think about it, the formation of coal took us from a much warmer climate to a much cooler one, in which everything around us evolved in that cooler space. And we've just dug it up again and burnt it. So we're reversing that process, which means we're returning ourselves very, very quickly to that warmer climate back in time, where none of the system that allows us to survive existed. We're just changing it. And we're changing it. We're not changing it on a geological scale, which is the millions of years that it took. We're not even changing it on the scale that we evolved in, which is the last like few 100,000 years. We're doing it in 200 years. Like no part of that system can cope with it. And the answer, like if you solve that problem, it's death. Like that's literally the problem. We've dug it up and burnt it. Like it got produced by photosynthesis. The opposite is combustion. Like, of course we're going back there when none of this was around. So I don't understand the argument. Like there isn't one. And I do understand why people don't know. Like, but it's a logical conclusion.
Yeah, I can feel like my heart feels the density of that, the abstract, like it feels like common sense. And a lot of people that I've grown and learned who hold authority, they want evidence, you know, and I'm looking forward. I think on our next talk we'll distill like some evidence of that's what's happening, you know, because I'm sure there's an abundant of evidence that people aren't aware that this is evidence that we're returning back to that previous cycle, and we're not moving towards like the Earth's natural trajectory. You
Yeah.
know, so that's so I think so. Our next talk will like we need to be clear on like where the Earth is supposed to be headed and what that natural trajectory looks like, and what are all like what are signs in the atmosphere on the Earth that is not that.
Right.
And then I'm sure from that we'll it'll also expose all the things humans are doing that are contributing to that, which will eventually lead to us talking about solutions. So, but that
Cool.
feels dark and heavy and a perfect place to stop.
Yeah, it's dark. Thanks.
Thank you, Robert. Yeah, your information is gold for us. Yeah, there's a lot of uncertainty, and having a right relationship with the planet and the world and the environment, I think, is the brightest hope I think we can have to meeting what the totality of what has already been created.
Yeah, that's what I think too.
Great. Okay. I will stay in touch and we'll do another one next week.
Cool.
Enjoy your trip back in Sweden and we'll talk soon.
Thanks. See you later.
Bye.